Welcome! This brief tutorial reviews the risk points of an AI project as identified in PMI's CPMAI AI Project Management Framework. CPMAI stands for Cognitive Project Management for AI, which is an agile project management framework developed by Cognilytica, who joined with PMI in 2024. Let's start with a definition of AI project risk. While there are a variety of risk definitions, they all have some common elements. For this tutorial, we will be using a composite definition that combines common risk elements from NIST, ISO, and ISACA, the definition of risk having a business focus. Risk is being defined as the possibility that uncertainty in decisions, assumptions, execution, or vendor performance will prevent a technology investment from delivering its intended business value, resulting in financial loss, operational disruption, or strategic failure. In short, a risk is any event that creates, or can create, a bad outcome on the development, operation, output, or performance of our AI project. It's common sense that project risks need to be identified to be mitigated. Risk management is an area that often gets ignored in a project. The diagram shows a unified risk management process. For any AI project, including a Gen AI project, risk management should be implemented along with a risk manager to avoid project failure. Now let's look at the CPMAI project management and development processes. AI projects are not like other software development projects, since its outcome is highly dependent on data. AI development is often referred to as being data-centric in that training of AI models, and its output comes from processing patterns in data. Conversely, traditional software development relies on program code to handle every possible scenario, and relies on rules and logic. In AI systems, the data itself is the primary asset and requires significant effort in collection, cleaning, labeling, and management. AI projects often fail because the development process is flawed due to poor models and poor training data. These factors result in faulty output that does not generalize to the outside world. For this risk tutorial, we will use PMI's CPMAI lifecycle as the framework to identify the risks that negatively impact AI development. CPMAI defines 6 phases that are iterative. The phases are shown in the diagram and are based on the Cognilytica CPMAI workbook and course from October 2023. Cognilytica and its CPMAI AI project management framework became part of PMI in 2024. The phases in the CPMAI framework are as follows. Phase 1 is the business understanding phase, which defines why you are using AI, what success means, and whether AI even makes sense versus using other programming methods. This phase may also start the discussion of ethical and responsible use of AI and/or review of any regulations that limits the model's public deployment. In essence, this is the traditional activity of writing the business case and justification for the project. However, questions to be answered is whether AI is an appropriate technology choice, why the project is feasible, and the generation of extensive ROI and cost estimates. Phase 2 is the data understanding phase, which determines whether the needed data to train the AI model exists, has a reasonable quality to be used for training, and if the data represents reality so the model will produce results that can be generalized to the real world. Phase 3 is the data preparation phase, which turns raw data into data that can be used for model training. Activities in this phase include data collection, cleaning, labeling, transformations, and, if necessary, data creation. Phase 4 is the data modeling phase. This phase is where model selection is finalized, the model or models modified if necessary, trained, and tuned. In many cases, AI projects leverage existing models and, if necessary, modify them. This phase begins the testing of the model to produce the desired results that project expects. Phase 5 is the model evaluation phase. This phase continues with the model's output testing and checking if the model meets real-world business usability objectives. Phase 6 is model operationalization. In this phase, the model plus additional supporting software, like user interfaces, data pipelines, and databases are deployed, monitored, governed, and maintained. The model may undergo additional real-world retraining as needed to ensure there are safety guardrails in place, so incorrect or unintended outputs aren't generated. While the phases were described in a linear fashion, PMP-CPMAI is iterative once you get past phases 1 and 2. Now let's review a couple of key development risks for each phase. The business understanding phase defines the business case and associated success criteria. AI is expensive, and a clear business case, ROI, development and operational cost estimates, and functional end-user success criteria establish boundaries to evaluate the project's success. Various metrics and success criteria identify stage gates to establish when the AI project ends up on a negative trajectory and is no longer a wise investment. The top risks that occur in this phase are solving a technically impressive but business-irrelevant problem. Identify if AI shouldn't be used and that a traditional software program rules would be less costly and outperform AI. There are no measurable success criteria, and you can't track the success or failure of the project and its investment. Lack of financial controls and poor ROI estimates resulting in the inability to monitor the investment and to manage costs. No risk assessments to determine if the AI project is technically and operationally feasible. Failure to perform an ethical and responsible use assessments that minimizes organizational liability due to user harm or bias before putting the AI on the market. Teams can confuse if an AI project is interesting with whether or not the project is useful and needed from a business perspective. Project owners have to ask, how does the AI project support the strategic mission of the organization? Many AI project failures are born in this phase. In phase 2, the goal is to understand the data needed to train the model, the characteristics of good quality data, and identifying data sources to produce the output desired. The top risks that occur in this phase are not identifying that available data is poor quality, not identifying that there is limited real-world data to use for training, not identifying severe bias in the pool of training data, not identifying legal or other access constraints to the needed training data. Lack of training data analysis results in poor quality model outputs. The risks in this phase occur because the AI team either assumes training data exists, training data is clean, training data represents reality, and does not adequately perform training data analysis. The old IT phrase of junk in, junk out is highly relevant to AI application development. The data preparation phase covers cleansing, augmentation, labeling, transformation of data into usable formats, and the development of data pipelines. This phase is like the ETL or ELT phases of data collection, conversion, or integration activities of traditional software projects. The top risks in this phase are data labeling errors and data noise, incorrect data transformations, data leakage or where unexpected data is introduced into training, and this contamination of data impacts the model's output, and inadequate data quantity and data pipelines to collect and prepare data for training. These risks appear because data engineers do not pay adequate attention to the collection, staging, and delivery of data for model training. The data modeling phase includes such activities as algorithm selection or confirmation if selected earlier in the process, model training, AutoML, tuning, and ensembles. The top risks that occur in this phase are trying to build an AI model versus using models in existence, data not being a good fit for training and the desired outputs, performance metrics not being used by the team to understand the interaction between data and AI output to adjust the training process, unexplainable black box models being used in regulated domains, ethical and responsible use not being considered, identifying all costs for computing, development, productionalization, and AI application maintenance. These risks appear in this phase because teams do not properly assess a model's output reliability and governance. The low-risk approach to AI project development is that if you can explain it, govern it, and afford it, you can deploy it. Now that you have a functioning model, the model evaluation phase goes back to the business case, ROI estimates, KPIs, KRIs, and business success criteria to evaluate the model's output. The risk questions here are whether the AI application will deliver the business value promised and produce quality output. The top risks that occur in this phase are ROI and business case not updated and validated, ignoring false positive and false negative metrics and the impacts on users, inadequate testing, no operational planning and acceptance testing, no ethics and responsibility reviews, An AI application that can ruin your business and turn off customers is not a good model. There are too many examples of these scenarios to discuss here, but all AI teams should become familiar with failure case studies as a way to avoid repeating the mistakes others have made. The model operationalization phase includes deployment, monitoring, governance, and maintenance of the AI model and application. The top risks in this phase are model and data drift, where the AI's output changes for various reasons, and additional training is needed to maintain the integrity of the output. There are no humans helping to review the AI's output to users, resulting in poor quality output being delivered. This is where harm to users can occur. No governance model to oversee proper use, performance, and maintenance of the AI application. A lack of governance can result in harm to end users, as well as create a legal liability to the organization. Last, the lack of end-user complaint monitoring or assessment. A poorly operating AI application can harm end users and do damage to an organization's reputation, as well as create legal liabilities. These risks occur because AI systems are living systems that decay, drift, and get misused. AI applications require oversight and governance to maintain their effectiveness. There are lots of resources to learn about AI challenges and shortcomings for data privacy, legal liabilities, deep fakes, creation of unintended responses, security, and hallucinations. The strategic takeaway is that AI has risks that threaten its effective development in every phase, but which can be mitigated with a good risk management and development process. AI project risks are not just development process related, but data quality, model integrity, and testing related. CPMAI, while not a risk management framework, provides risk mitigation guidance to the AI team throughout the development and delivery cycle. We hope you found this information useful, and thanks for watching this tutorial. Visit CoffeeCat Solutions website at coffeecatsolutions.com for more risk management tutorials, to download sample risk tools, and to review our risk management services.